Weak acids and weak bases do equilibrium, so they don't completely dissociate, and we get to do more rice tables to deal with them. We'll use initial concentrations, and depending on what's going on, we'll either use pH or pOH, and we'll use additional steps if we have a weak base, if we need to go from pOH to pH. But we know how to deal with those. That's not that bad, right? Here's a problem. Here's acetic acid. I shouldn't say it's a problem. It's a puzzle, right? It says acetic acid is going to be used, right? What is the pH? They're giving you the molarity of the acetic acid, and then they're giving you the Ka. All right. We just mentioned that we should use a rice table. So R is for the reaction. It's acetic acid. I'm going to choose to write that in this form rather than the form that tells you about the structure. This, remember, is a liquid, so it won't appear in the equilibrium constant. This is going to form hydronium ions and acetate ions. Since this is a rice table, I'm going to say, I want to make sure that I keep clear which side is reactants and which side is products. Initially, that's the I, initially, they told me it was a 0.035 molar solution. This is a liquid. It doesn't appear in the equilibrium constant, so I don't have to write anything for that. All the way through, I don't have to write a darn thing for H2O. Initially, it hasn't fallen apart. C for change. Well, some of it's going to fall apart. I don't know how much, therefore X. When it falls apart, it's going to come into existence over here. So these both become plus X. And at equilibrium, we will have these two things added together. So at equilibrium, we see this. They're telling me what the Ka is. They say the value of Ka is 1.76 times 10 to the negative fifth. I know that Ka is created by using the concentrations of hydronium ion and acetate ion here over the concentration of acetic acid. I have all of those right here. So this turns into X squared over 0.035 minus X. This is going to lead us to a quadratic equation. So I'm going to be coming up with the quadratic equation and then using the quadratic formula to solve it. My quadratic equation will end up being X squared plus 1.65 times 10 to the negative fifth X and minus 6.16 times 10 to the negative seventh equals 0. I've done all the algebra already. You should make sure that you do the algebra yourself so that you get the same thing. If I am trying to use a quadratic formula on it, I know the quadratic formula says X equals minus B. Well, that's B, so minus 1.76 times 10 to the negative fifth. It also says the next thing should be plus or minus. But if I leave this as minus, I'm going to get a negative value, and I can't create a negative amount of stuff. So it turns out I can just do the positive. All right, so this would be the square root of B squared. So there's 1.76 times, where'd my 1 go? Times 10 to the negative fifth squared minus 4AC. Well, there's already a minus on this, so plus 4 times C. I'm putting a little things in there, and that all is under the square root sign. Divided by 2A. Oh, well, that's good. I like that. That was the easy part. when you get all done, you should come back here and remind yourself that X is going to be the concentration of of the hydronium ion. Well, I'll put in some steps, why not? I'm keeping way more digits than you're going to want to keep at the end. We'll get rid of them though. So this, oh, that's another 7. All right, I have a concentration of hydronium ions. That's not what they asked for though. They asked for the pH. Oh, that's okay. We can do the pH. It's just minus log of this number that we just came up with because that's concentration of hydronium ions. So when I do that, it's a minus log of 7.76 times 10 to the negative 4th. And we're going to get that that's 3.11. And that's an acidic value, which makes sense because we are talking about acetic acid. So we're happy with the number that we came up with.